All right, we are recording. I'm going to share the screen. All right, so I'm going to exit out of this. Okay, so let's go to Brightspace and let's go to ITS 365. So this is your next homework assignment. We're going to go to content, and it is CIFAR-10. I did decide to do CIFAR-10. It's honestly like the best, most challenging thing at your level, so it makes sense to do that one. All right, so I'm going to scroll down here. You can see we're basically done with this classic iris torch, hot field networks. We've done that. I still need to do this lecture. It's just a lecture. You guys know how to use these metrics. It's just like the math behind it. Here, I just have a whole bunch of slides, notes, so I might go through those at the end of class today. This is today's topic, cross entropy, and a few other things. And here you go. That's the homework assignment. It's the homework CIFAR-10 challenge, DNNs, CNNs. Okay. So what I've decided to do this semester is I'm going to do 2 stages for this homework. It's going to be like stage 1 and stage 2. Okay. Stage 1 is the competition with just deep neural networks, but nothing beyond that. So no advanced algorithms. And then stage 2 will be with advanced algorithms such as CNNs. Do you see the difference? So make a note of that, right? Because that's important. But I think that's actually, it'll help you to better understand how this works, to be forced to solve it with just deep deep networks, and then to move on to a more advanced algorithm such as a CNN, which of course I need to provide a lecture for that. That's once we finish these topics, then the next set of lectures is ResNets and CNNs. So that's the last part of this. So it'll be 2 homework assignments in a sense with the same data set. Do you guys understand? This is also technically a competition. Okay, so you guys, we're gonna do a goal. We're gonna set a goal, which is this is a competition, and one of you should win, right? So who wins? The person who gets the highest F metric on the testing. So you have to abide by the rules of this, right? And that's how you will really learn everything that you have to do. For instance, if you want to win, you got to use a GPU. Someone that uses a CPU will lose. You see that? You will learn also the difference between building a deep neural network and using a CNN. It might surprise you that a CNN will actually use, even though it's a more advanced algorithm, it uses less RAM. So you will learn that difference actually also. Okay, but I'll show you some tricks of what you can do with the deep neural network. We're gonna use a compression technique called singular value decomposition, which will help you to take a data set that's really large and just make it smaller so that it fits in your RAM memory. So we're going to use all these tricks and tools, right, just so that you can complete the task, but also try to win within the boundaries. What some of the rules are, you're going to have to use PyTorch only, no other frameworks, and you can't use advanced libraries like Fast AI or something like that. Only PyTorch. But you can use transfer learning, right? And so you'll have to learn to understand what that means, okay? But that's for stage 2. Stage 1, you can do already, because it's everything that we've covered in class. So that's the whole point. So stage 1, you can do it already. Stage 2, I still need to cover some topics. Yes, sir.
So would learn be considered a advanced library that we can use, or is that
You can use sklearn, but you're going to lose probably. But like a classifier in sklearn, maybe, but you're going to lose, in my opinion. But yeah. So that's why I make it a competition, because if I make it a competition, then you have to be creative. You gotta be, the prize is just, it's a trophy, right? So it's a 3D printed lion of the university. And I'll do that for stage 1 and stage 2. So it's not like you have to win to get an A, right? So just do a good job and you'll get a good grade. But to incentivize the competition, I do make like a little trophy for each stage. It'll probably be like a silver one and then a gold one for that. All right, but it should be a good one. I mean, if we go through this exercise, you'll understand a lot about machine learning, right? Because, one of the things is the data set is massive and, we're doing images, they're color images. And when you start building a very deep neural network with all those weights, it's not going to be like the perceptron 16 weights, right? Now it's going to be many, many, many weights. So, yeah. Any questions so far? All right, so let's take a look. Oh, yeah, go ahead. For this one, I do want everyone to present. But a quick presentation. Right, it's not in real time. Yeah, I trust that you guys are not cheating.
Yeah, no, I was just saying.
Yeah, that's smart. Yeah, no one's cheating here. I mean, it's not like it's a gold trophy, right? It's plastic. And so, but the point is to win. Remember, you have to, when you say my F1 measure was this much, it has to be out of 10 runs, not just one time. Remember that if you just do one time, you might get lucky and get a really high F measure, or you get a very low F measure. Yes, exactly. You need to say something convincing. I accept, for instance, you say, I did 10 and the average was this, and then that's your F1 measure. You see that? And obviously, if somebody gets 85 and someone gets 86, that's very close, right? So, I mean, at the end of the day, we would go with that, but we do need 10, the average of 10 for something like that. Got it? Yeah, go ahead. Uh-huh. I'll provide the data sets. Yeah, I have a link here. So I'll go over all of this right now. Yeah.
So what are you looking for? For again.
How you won. Because I give you the code, right? So it's the same, the code you have at this point is what you can use. You just have to modify it. Like, your vectors, we were doing wine, which was a vector of 11. What do you have to do with the images? You have to spaghettify them, right? And it's going to be a much larger vector, maybe 3,000, I don't know. So think about that. That's a massive dimension. And so even if you have a GPU, you'll be very surprised that even the GPU, that's a lot for the GPU. So then what are the techniques that we can use? So in this case, compression, right? Which is we have several techniques such as principal component analysis, singular value decomposition. So I'll talk a little bit about them in the theory and you'll see they're very easy to use. But that's essentially what I foresee because, if you start using the data as is, you'll see that it's big and it's difficult. So the best first attempt might be to compress it and see what happens and see what your score comes out to. And then from there, play with it until you win. That's stage one. Stage two, it's going to be different. It may not require compression because we will be using a more advanced algorithm called the CNN and transfer learning, which we have pre-trained models such as ResNets, VGGs, and so on. See, I'll discuss some of those. Make sense? All right. So this is an image-based homework. Everything we've done so far has been very tabular, right? Tabular data. We don't really do that much in the realm of text processing in this course. So if you're interested in large language models and things like that, we do have courses for that, ITS 530. But here, everything has been tabular so far. And now we're going to switch to image processing, right? Which is the classic thing. So this is the homework. Essentially, these 3 links should provide everything that you need, I think. Here's the link for CNN background if you want to start reading through it. This is something I will cover later in the semester, obviously, during like the third of the class after the exam. Essentially, it's got the same ideas. You still get a confusion matrix and all that. You just use an algorithm called the convolutional neural network, and ResNet are just very deep convolutional neural networks with some additional tricks in them. All right, so we'll talk about that later in the semester, but this is kind of the theory. This is stage 2 of the homework. All right, so I provided that link already. For stage 1, you already know the theory because it's that chapter 4. All right. Here's a few. So I clicked on this one. Then I have 2 other links. Right. Let's go to this one. As usual, so this one just takes you to a repo I have in machine learning foundations, neural net, PyTorch. I have all these Jupyter notebooks. So these are things that you can use for this homework. So I'm not really like expecting you to write code from scratch. You can use this code, but just learn how to get the best results possible. Do you guys see that? So definitely that one. There's a few Jupyter Note, these are different versions that I've tried. In class CIFAR-10 challenge. So you can see I've provided a script here. So play with these because this is one thing I will not demo in class, okay? I'm giving you the code, but I expect you guys to get this to work. But yeah, here's the example. These are the commands. Once you're on the GPU, you can run these commands to see that you have a GPU. So for instance, if you run torch CUDA is available and it says true, that means you do have a GPU. Okay, that's important. If this says false, obviously you don't have a GPU. It'll tell you how many CUDA GPUs you have. It'll even tell you which version of CUDA you have. Okay, so that's one thing. Then here is essentially all you have to do is for this challenge, I have provided a link. And you will download the data and then put it in these folders. You can see this is on my computer even, CIFAR-10 images, and you have a train test and a test set. Remember, don't cheat on this part. You should use the train set to train, right? But you should never show the test set to the model, right? After training the model on the train set, then you evaluate it on the test set. So for the competition, I'm assuming that the scores that you're getting are just from the test set and that the model never saw that data, all right? If it was a real competition, you would only get the train set. No one would give you the test set, and then you would have to go to the competition, take your model, and on the day, they would give you the test set and you would run it. But we don't have time for that, obviously. So did that make sense, guys? Are there any questions about that? Yeah, due dates for these. So what you got to think about what we have left. So mainly now I have like theory-based topics, like just explaining what cross entropy is. So there won't be a homework for that. The week after will be maybe CNNs and ResNets. And obviously that's the homework we're doing. So there may be one more homework assignment and then the term project. All right. And so essentially we're currently on week 9. So we have the rest of the semester to finish this. So every 2 weeks, maybe one of these would be due. You see that? So stage 1 might be due 3 weeks from today. And then stage 2 might be due 4 weeks from today.
And we're expected to be working this post spring break, right? It's not like we absolutely need 3 weeks, or it's like
now and work all through spring break every day. Yeah, no, I get it. You guys are gonna take a break during spring break. That's fine. But I'm giving you the assignment now. I'm giving you all the code. Play with it when you have time. Yeah. You should 2 weeks, when you come back. Right, I get your point. So let's say it'll be not the week right after spring break. It might be the second week or the third week. But then right after that, we'll do one every week. So stage 1, stage 2, and then really we're at the end of the semester, so the term project.
Okay, I see.
Got it?
Yeah.
Yeah. So I don't want to give you a fixed date, but yeah, probably it would be, what is it today? 3 weeks from today. might be when we do stage one. Got it? All right. And like I said, there's a lot of challenges, and really it's not the code that's going to be the challenge. The challenge is going to be to get this to run on a GPU. That's going to be the hard part, probably, if you want to win. And, this code already shows you how to load the data and everything. So it's not even that. Make sense? All right. So you can see the code here. There are several versions of this code, right? So some versions use a CNN, some versions might use a ResNet, and some versions just use a deep neural network. So you can see that, this shows you the data loaders and how to load the data. Shows you the images. So this is CIFAR-10. As you can see, they're very small images, but they're in color, which is nice, right? Because it's more challenging to process something in color than when it is in black and white. But obviously, color is really important here. All right. The balance of the data, as you can see. What do you conclude from this histogram? We have 10 classes, and the data set is what? Balance or imbalance? Balance. Exactly. It's a balanced data set. And then you load the test set, also balanced. And you'll have you'll do your training, you have your performance metrics, and look at that. What do you see there? Is it a good performance? It's really bad, right? But I promise you can get up to an F. So the F measure here is what, 0.13? You can get that F measure. I think the record, I don't remember exactly, is one of the students that I've had in the past, and I think we hit almost 90, 92. So it's definitely possible. But you got to know how to do that. Got it? So that's it. So your entire goal is to take this F measure from 0.13 to 0.90 and win. Okay? And you need a lot of things to help you do that when you're processing this data. All right, great. So so I provided this Jupyter notebook. That's stage one. Remember, stage two is using the ResNet, which is other things. So you can take a look at all these scripts. All right, I think I have one more link. So we clicked on this one. So let's do CIFAR competition. Okay, so here are my instructions, and I may change these as students, think of ways to get around them. So I have to, but essentially to make it fair, using the CIFAR-10 data, you must use the data set I provided and nothing else. So don't try to, I can find it from data sets and just download it. You got to use this one, okay? We got to keep it fair. The rules, PyTorch only, no TensorFlow, no Keras, no FastAI, no other frameworks, transformers, no transformer for vision or anything like that. Keep it within those rules. So PyTorch only, raw Python, I would say, pure Python. Must use my code and modify from there. Don't ask ChatGPT to write you the best code possible, which you could. Just please use my code, and that's the best way to learn, right? To understand, something basic, and then add to it the ResNet part and so on. Yeah, please. Yeah.
Have developers actually have they tried using ChatGPT yet to create its own AI model and evaluate how it does?
ChatGPT can do a pretty good job of creating model. I use ChatGPT all the time now. So before, I would think about my life before. I would get a paper, read that paper, try to understand it, go to the repo, write that code, something wouldn't work. I would spend months trying to figure out what the problem was. And eventually I would get that paper and I would know how to run it. Now I don't do that. Now I read the paper, look at it, understand what it's about, go to ChatGPT right away and ask it to give me a very simple, PyTorch version of that. I'll ask it, do you know this paper? It usually says it does. And then I'll ask it, can you give me a very simple piece of code of the main ideas of that paper. I read it and I get a lot from that. And then from there, I read it again, and then I can develop my own code. But that little part, that part where it gives me some simple code is very helpful. So, and it can create more complex code. It's just it makes mistakes still. So ChatGPT still makes mistakes, but it's getting better.
Okay, so it makes like fairly decent AI models that just need a little bit of cleaning.
Exactly. So yeah, so I don't trust it fully, but it's I can tell you it's really helpful. Like I get, like that's my process now. I just read a paper or a topic. Somebody asked me the other day about some speech thing and I didn't know what it was. I just asked ChatGPT to explain it to me. I got it like immediately. It was such a good explanation. And then you just have to read it, but verify or corroborate. And with code, it will have a few errors here and there, but it's good enough that you can solve. So sometimes, you read the math and it's not quite clear how they did it, but once you see in the code, it's easy to understand. All right. So yeah, so let's go back to the rules. So PyTorch only, must use my code and modify from there. So I wrote on here, no Keras, no TensorFlow, no Hugging Face transformers, no fast AI, and I should say, etc. Right? Don't use any of those because that's a different topic from what you're learning here. Try and train and test a PyTorch model from scratch using CIFAR-10, the CIFAR-10 code. You can incorporate, and I'm going to change this because last semester I just did one stage, but I've realized that it's better to do two stages. So in stage 2, you can incorporate a pre-trained model from Torch Vision into the code as long as you fine tune it with the CIFAR data. So you'll have to learn what that means, obviously. That's one of the topics I have to cover. The pre-trained model cannot have been pre-trained on CIFAR-10. Show all relevant performance metrics and win. The highest F1 score on the test set will win. Last semester, I had 2 students that almost got into a fight. Okay, so also, I'll let you guys decide. I'm not going to decide who the winner is, right? So you guys will vote, right? And just, again, don't take it too serious. It's just for fun, okay? But some of you can get very competitive. All right, yeah, so I'll modify this a little bit just to reflect that there's going to be stage 1 and stage 2. And I'll have 2 links. So it'll be 1 link for stage 1 and 1 link for stage 2. Does that make sense, guys? And then the last thing should be this. This is the data set. So this goes to my repo where I sometimes will add things. If there's errors, common problems that students are facing, you can see here I have in this link, I have a copy of the Jupyter notebook as well. The same one we looked at. Sometimes I tweak this a little bit. So whenever I load a script, I don't delete the old one. So just look at all of them if you can. Right. This just shows, I think, how to read the data essentially. The data is located here. So it's actually someone else's repo, Yoon Kim. All right, so I'm going to click on that. Hopefully that's still available. Yeah. So this is one of the nicest ways of getting the data set, in my opinion, because you just have to download the zip as you know, and so CIFAR-10 images in JPEG format, and you can clone the repo. So if I click on train, it's got the classes. So the classes are assigned by the folder. Right? So you can see you have airplane here. So you can get the labels from that. And then you have these images of airplanes. So if you click on this one, should be an airplane of some kind. The images are tiny, and that might surprise you, but we always have to make our images small to run on these models. But yeah, you get the label from the folder that contains the image. That's No questions? All right, so consider this assigned. So you can start working on it right now if you want. You can try to run this on your CPU If you don't have a GPU yet, just select a random, maybe use the test set for that, just to kind of, because it has fewer samples, right? And just see what happens, just to get it going. But remember, eventually you'll have to run this on the GPU, so maybe try Colab, and hopefully we'll get the Scholar fixed. Okay? Yeah, that's it. All right, so homework is assigned. No questions? Great. And I'll modify this later today or tomorrow with the stage 1 and stage 2 information. All right, so I'm going to close this and I'm going to stay here. Okay, so this is what we're doing today. Okay, so let me create a new